Hey everybody, this is Mr. McKee again with Net 226. Today I'm going to be going over Packet Tracer 5.2.7, which is configure and modify standard IP version 4 ACLs. Alright, and looking at our topology, we have an edge router going out to the internet, and then there's a server out there. Office 1 has one router, and Office 2 has another router. Each of those routers on the bottom have two LANs connected. All right, and here is our router our addressing table. All right, nothing really major change up there. All right, so network security and traffic flow are important issues when designing and managing IP networks. The ability to configure proper rules to filter packets based on established security policies is a valuable skill. In this lab, you will be filtering rules for two business locations that are represented by R1 and R3. Management has established some access policies between the LANs located in R1 and R3, which you must implement. The edge router sitting between R1 and R3 has been provided by the ISP, which will not have any ACLs placed on it. Okay, that's fine. You will not be allowed any administrative access to the edge router because you can only control and manage your own equipment. Pretty normal. All right, instructions. In part 1, verify connectivity between devices. It is very important to test whether connectivity is working before you configure and apply access lists. You want to be sure that your network is functioning properly before you start to filter traffic. Okay, so going through this packet tracer, there's 25 questions to answer. All right, I marked them all with answer in red text. All right, so there'll be a Word document in the submission link in Moodle. So you'll be submitting that Word document, you'll be submitting the .pka file, and the your completion rate with your name listed, or username listed. All right, so let's see. We're going to ping from, and all these are questions, by the way. All right, from ping from PCA, ping PCC, and PCD. All right, so .168.30.3, and what I'm going to do too is copy this. All right, that one's good. Let's do 40.3. All right, that one's good. So that first one's fine from R1. From R1 ping. It wants us to ping from the router? Sure. I think it's ping. Yeah, it's just ping. I'm thinking of a Palo Alto firewall that's ping host. All right, ping C and D. So can I paste into that? Nope. 92.168.30.3. All right, we got responses back from that. Let's see, 40.3. All right, that looks good. All right, from PCC, ping PCA and B. Let's do A first. All right, good response back from that. Let me just copy this. All right, that's good. So we have that from R3, ping A and B. Oh, there we go. All right, it's working now. .10.3. All right. 20.3. All right. So that's good. Okay, can all the PCs ping the server? Well, let's find out. All right, ping 209 dot, whoops, dot 165.200.254. Copy this. All right, that one, this one. All right, we're getting responses back from those. I just do all these together. Good response is good response. Whoops. Good reply. And finally, all right, good replies. All right, part 2, configure and verify standard, numbered, and named ACLs. Standard ACLs filter traffic based on the IP source address only. A typical best practice for standard ACLs is to configure and apply an ACL as close to the destination as possible. For the first access list in this activity, create a standard numbered ACL that allows traffic from all hosts on the 10.0 network and all hosts on the 20.0 network to access all hosts on the 30.0 network. The security policy also states that an explicit deny any access control entry, or ACE, also referred to as an ACL statement, should be present at the end of all the ACLs. All right, what wildcard mask would you use to allow all hosts on the 10.0 network to access the 30.0 network? All right, well, the wildcard mask would be the opposite of the 255.255.255.0, which, so it would be that. All right. All right, so so wildcard mask is 0.0.0.0.255. All right, following Cisco's recommended best practices, on which router would you place the ACL? All right, so permit 10 and 20 to access 30. So we'll put that on R3, since that's the router going out closest to 30.0. So let me just make sure. PCC. Yep. All right. So on which interface would you place the ACL? All right. In which direction? Where's that? On which direction would you apply it? It should be applied going out, that interface. All right, so closest to what you're restricting access to. All right, so let's go ahead and configure the ACL on R3. All right, let's do a config T access list 1 remark allow R1 lands access. All right, access list 1 permit to 168.10.0 0.0.0.255. Make sure that's right. Okay. And I could just highlight this also and do it like that. If it'll let me. Copy. Yep. And access list 1 deny any. So do this, comment, do this, deny everything else. All right, apply the ACL to the appropriate interface in the proper direction. So interface gigabit 000 IP access group 1 out. Okay. Verify the numbered ACL. The use of various show commands will help you verify that both the syntax and placement of your ACLs in your router. All right. To see access list 1 in its entirety with the access control entries, which command would you use? Let's do all right, show access lists 1. All right, there's my access list. And there's my 2 entries. All right. Which command would you use to see where the access list is applied and in what direction? I would do show IP interface gigabit 000 outgoing access list 1. Or you could just do show run if you wanted to. You could see the access group 1 output on the interface, and right here is the actual, there's the remark, allow the remark permit deny any. Okay. On R3, I think I already did that. Show access lists. Okay. Wildcard bits, deny any. So okay, I don't know why I did that. I guess to figure out if you couldn't figure it out, it actually tells you the answer to this down here. All right, show IP interface, gigabit 000, and once again, the outgoing access list is 1. And notice right here, inbound access list is not set, so it's definitely outbound. All right, so 3, test the ACL to see if it allows traffic from 10 network to access the 30 network. From PC A, ping PCC. And let's see, PCC is that one. 30.3. 192.168.30.3. All right, I'm doing good there, so yeah, that let me do that. All right, where are we at? All right, ping was successful there. Test the ACL to see if it allowed traffic from the 20 network to the 30 network. From PCB, ping PCC. PCB. All right. Whoops. 168.30.3. All right, so yes, we can ping there. All right, so yes and yes. Should pings from PCD to PCC be successful? Yes or no? Ping PCD from PCC. Wait. Oh, ping from PCD to PCC. And it is ping 192.168.30.30. That's where it is, right? 30.3, yes. Right. Destination unreachable. It's hitting the, that's the 40.1 interface is router 3's default gateway right there. So that's where it's stopping. It's blocking it. All right. It's actually blocking it right here, though. It's not blocking it there. It's just, that's the last successful response. So 40.1 is telling you your destination host is unreachable. All right, let's see. So it was not successful. It shouldn't have been successful because the ACL from R1 prompt ping PCC's IP address again. From R1's prompt. All right, so you guys see that? Success rate 0. If we do a trace route to 30.3, oh, let me do trace route. But let's see. So it's actually pinging. Let's see. 10 R3 0, 0. Let's see. R1. So R1. So you're sending a ping from here, right? No, R1, right there. So you're sending a ping out this interface. It's on this network, so that's why it's not going through successfully. It's because that's on a different network than the 10.0 or the 20.0 network. Okay. So issue the show access list 1 command. Again, note that the command output displays information on the number of times each access control entry was matched by traffic that reached interface gigabit Ethernet 000. Okay. All right. So you got a couple matches there, a couple extra denies because I typed it in a couple times. All right. Step 2, configure a named standard ACL. Create a named standard ACL that conforms to the following policy. Allow traffic from all hosts on the 40.0 network, access to all the hosts on the 10 network. Also, only allow PCC to access 10 network. Allow traffic from all hosts on the 40 network to access all hosts on the 10 network. Also, only allow host PCC access to the 10 network. The name of this access list should be called branch office policy. So, following Cisco's recommended best practices, on which router would you place the ACL? So, closest to the machine that we're putting the ACL to. So let's see. Okay, so we're going to put that on R1 because that's closest to the 10 network right there. Let's see. It kind of gives it away right there because it shows you. On which interface would you place the ACL? In which direction would you apply it? Well, I would put it on the, what's this? Gigabit. Come on. All right, gigabit 000 out. Okay. It doesn't tell you that, but well, it actually does it down here, so yeah, it kind of tells you. Config T access list standard all caps branch office policy. All right, permit host 192.168.30.3, which is PC3 or PCC. All right, and permit 192.168.40.0. So everybody on that network 0.0.0.255. All right. Because allow all traffic from hosts on 40, that's there, and then only allow PCC to access 10.0. Okay. All right. So look at the first ACE in the access list. What is another way to write this? All right, so let's do a show access lists. Okay. Host that one, this one. So look at the first ACE in the access list. What is another way to write this? Well, you could write that with a wildcard mask of all zeros, because that means use just this. It'd be the same thing as a 255.255.255 network, which is a \32. So you could do a 0.0.0.0 wildcard mask. All right. So that answers that. Apply the ACL to the appropriate interface in the proper direction. And we did say gigabit 00, and we did say out. So let's do config T. All right, IP access group. Office policy. Access group, out. All right. Verify the named access list policy. I already did that, but I'll do it again. Exit, exit, show access lists. Okay, so it said apply that up there, verify a named ACL. Okay, saw that. Is there any difference between ACL and R1 and ACL and R3? Yeah. We're only blocking one host there, or allowing one host there, and we're allowing a whole network there. So over here, it's two complete networks. And we're implicitly denying, but they explicitly denied the everything else there. Okay, so that's the big difference. We implicitly denied here, but it was explicitly denied there. So that's the big difference. Best practice is to explicitly deny it so you can see it in there, and also you'll see your matches. All right, your number of matches. All right, so let's see. R1, let's do show IP interface gigabit 000. All right, outbound access list is branch office policy. Okay. Test the ACL. From the command prompt of PCC, ping IP of PCA. All right. All right. 2.168.10.3. And it says, let's see. All right, I lost my place. We did that. We did this. All right, where are we at? Test the ACL. From the command prompt of PCC. All right, it was successful. All right, so part 2, step 3 is test the ACL to ensure that only the PCC host is allowed to access the 10.0 network. You must do an extended ping and use the gigabit interface on R2 as your R3. All right. So like this, ping. .192.168.10.3. Oh, did I mess that up? Let's do it. All right, IP address 192.168.10.3. All right, repeat count. Enter, enter. Extended command, yes. 192.168.30.1. Type service 0. Okay. So that wasn't successful. Success rate is 0. Test the ACL to see if it allows traffic from 40 to reach 10 from the PCD command ping PCA. Alright, we already have PCA up. From PCD, wait a second, ping 30.3. Am I doing that right? Oh, I'm pinging the wrong thing. That's what I'm about to say. It's not right. It's not working. All right, let's do 10.3. All right, yes, it is successful. All right, so we're going to modify a standard. Let's see, all the way down here. Modify a standard ACL. It is common in business for security policies to change. For that reason, ACLs may need to be modified. In Part 3, you would change one of the ACLs you configured previously to match a new management policy that is being put in place. Attempt to ping the server at 209.165.200.254 from PCA. Note that the ping is not successful. And let's just make sure that is the case. All right, 209.165.200.254. All right, it is on timeout. All right, the ACL on R1 is blocking internet traffic from returning to PCA. This is because the source address in the packets that are returned is not the range of permitted addresses. Manage has decided that traffic that is returning from this is the network of the web server. Network should be allowed full access to the 10 network. Management also wants ACLs on all routers to follow consistent rules. A deny any ACE should be placed at the end of all ACLs. You must modify the branch office policy ACL. You'll add 2 additional lines to the ACL. There are 2 ways you could do this. Option 1, issue a no IP access list standard branch office policy command in the global config mode. This would remove the ACL from the router. Depending upon the router iOS, one of the following scenarios would occur. All filtering of packets would be canceled and all packets would be allowed through the router, or because you do not move the IP access group command to the gigabit 01 interface, filtering will still take place. Regardless, the ACL is gone and you could retype the whole ACL or cut and paste it in from a text editor. Option 2, you could modify ACLs in place by adding or deleting specific lines within the ACL itself. This can come in handy, especially when ACLs that are very long. The retyping of the whole ACL or copy and pasting can easily lead to errors. Modifying specific lines within the ACL is easily accomplished. For this activity, use option 2, and we will. Alright, so modify the named standard ACL. From R1, let's do Control C and then show access lists. Alright, so there's our access list. Alright, add 2 additional lines to the end of the ACL from global config mode. So let's do config T, IP access list, standard, oh come on now, office. Alright, make sure I typed it in right. Okay. So 30 permit 209.165.200.224. And notice that's a 0.0.0.31 because it's a backslash, what was it, 27? All right. So 0.0.0.31. So 32 addresses in that wildcard mask. 31 plus 0. All right. 40 deny any for a explicit deny. And okay. Verify the ACL. On R1, issue the show access lists. Show access lists. All right. So there's our allow that, allow this IP address, allow this network, allow this this network also. All right, and explicitly deny any. And do you have to apply the branch office policy to gigabit 01 interface in R1? Well, which one is it? Whoops, interface. The interface does not exist. Am I on the wrong one? Let's see. R1. Oh, I know why. Because that's the wrong freaking thing. It's so weird. That's gigabit 000. All right. So you don't have to do it. It's already on there. That's an error in the... Where's that? That should be gigabit 000. All right. Test the ACL to see if it allows traffic from the network to return to the 10.0 network from PCA. Ping the server like we already did. All right. So we should just be able to do up arrow. All right. Now we get a response. So it's allowing it to go out. It's just not, you're not getting replies back because it's filtering it out. All right, so as you can see, standard ACLs are very powerful and work quite well. Why would you ever have the need for using extended ACLs? All right, pretty much, you guys can look that up in the chapter, but pretty much the extended ACLs, they on a more complex network, you can be more granular with your access control lists, and filter out certain ports and stuff like that. And an standard extended ACLs, you can block traffic closer to where it originates from, so it can reduce the amount of bandwidth going across your network that doesn't really need to do that. All right, so more typing is typically required when using a named ACL as opposed to a numbered ACL. Why would you choose named ACLs over numbered? Well, obviously you can recognize them really easily. And another good reason to require named ACLs as opposed to numbered ACLs, you can you're able to modify specific lines within the ACL without having to rewrite the whole thing. But yeah, being able to recognize it too and what it's doing is good. And I think that's it. So what you have to do is submit your PKA file submit all the questions, which there's 25 questions in there, and then your completion right there. And if you got anything wrong, there's not a lot to do there, but copy that if you need to. All right, and that's it. Thanks for watching.